Now we're going to use the model we calibrated using our 2012 data to apply to the 2013 data. So importantly, all of the model fitting, that is the creation of the neural network, the calibration of the neural network, all of that was already done using information from 2012. So that's what's referred to again as the internal validity. Now we're going to look at the external validity of the model by applying it to 2013's data. So first and foremost, a lot of this will look very, very similar to what we did for 2012. I'm going to go ahead and copy and paste right here. These are the variables that we are going to use. These are the exact same variables as we had in 2012, except we've changed the year, right? So in the case where we had variables that have year variation, we've changed, for example, in this case, 2012 to 2013. Now, note we are able to still use, for example, the elevation. So if elevation proves to be important for predicting conflict, then there's no reason we can't use elevation in both 2012 and 2013, even though it doesn't change, right? I mean, elevation stays the same no matter what year you're looking at, for the most part, unless you're looking at very, very small changes, which we are not here. So you can still use this variable, even though it doesn't change over time. However, a lot of these do change over time, and so accordingly, we've changed the year that we're taking the measurement from. Now, scrolling back up, a lot of other things will also be very, very similar. We're still going to need to drop data just like we did in 2012, and we are still going to have to create our variable that we're going to predict just like we did in 2012. So I'm going to go ahead and copy these. So down here, I'm going to highlight all of this and copy it down. And all we're going to do here is to change the 2012s to 2013s.
So this becomes 2013, 2013, 2013, and then over to 2013, 2013, and finally 2013. So just like that, we've now changed all of our data to be 2013.
So this just gives us the data frame we need to actually do our predictions. Now, you'll note up here, the next thing we do is we import this MLP classifier, and then we do the construction of the network and the fitting of the network. Again, don't worry too much about the nuance of what's happening here, but this is where we're actually fitting our machine learning model. We're not going to do that with the 2013 data because we're going to use the same model that we created right here. The only difference is when we do our prediction, here we do our prediction using the 2012 values. In the new 2013 model, we're going to be doing our prediction with the 2013 model, 2013 values. So we're just going to skip straight to the probability prediction this time. So I'm going to copy this and paste this right here. And I'm going to change this 2012 to 2013. And that's it. So now we can use the model we calibrated based on 2012 to predict into 2013 to see how good this model does when we're trying to predict the future. So I went ahead and ran that, and just like we did before, we can look at these probability predictions. So these are the same as before. The second number is the probability that conflict would occur. The first number is the probability conflict would not occur in every single unit in Rwanda. And what we'll do is we're going to actually look at this in the same way we looked at the 2012 data. We're going to look at these class accuracies in the same way. So I'm going to go ahead and, again, just copy this from our 2012, paste it right here. I'll put it right here. And this is still the same, probability prediction, that's fine. We can leave this the same. We'll want to change the Y value to 2013. So that is, we want to actually look at the deaths that occurred in 2013, not the 2012. The same prediction and truth that we described before, and this will be the same as well. So I'm going to go ahead and run this. And so here we can see, if we take our 2012 model and apply it to 2013, cases where there was conflict in 2013, we're ascribing around a 1% probability that conflict would have occurred. Conversely, if we look at the places where conflict did not occur, we have a very, very, even lower, 0.3% probability. So this is actually, our model is doing better in the 2013 case. The external validity of our model is better than the internal validity. Now, again, both are atrocious. We would not use these models in practice. They are, simply not performing very well at all. However, in 2013, at least we're ascribing a higher probability to the places, 3 times higher, to the places that are likely to have conflict. And so that's it for prediction. Just to briefly recap, what we went through was actually downloading the data from a streaming zip, going in and identifying if we had appropriate data to do the modeling with, finding the variables that we believe were most meaningful for predicting conflict, integrating it into a neural network model, and then comparing the external and the internal 2012 accuracy and the external 2013 accuracy.